Welcome everybody to INFUSION20. My name is Mike Pacheco. I am with McElroy Manufacturing and I am the Innovation Product Manager. So I'm responsible for McElroy's digital products. And we're pleased to have you all for our first online Infusion event. And today I'm really excited to announce Casey Britton from Fusion Technologies, who's here to tell you all about an exciting game changer in our industry, and that's using an Acrobat on an HDPE job. So Casey, welcome.
Thank you, Mike. It's an honor, and I'm really excited to be a part of Infusion this year and share our experience with the Acrobat 250 with everyone. We use the Acrobat 250 on an HDPE project, and until you let us in on it, we didn't know that the Acrobat was suitable for HDPE. We were aware that that series of equipment was designed for PPR, and because we live in the HDPE side of the house and industry, it was just not something that we had had a serious look at up until this particular project. So before I get into the details about the Acrobat and tell everyone about that experience, I'd like to take a moment to introduce myself and Fusion Technologies. And then I'll provide a little bit of background information about this project because I think it's very interesting. And then we'll get into the details on how the Acrobat performed for us. So my career in HDPE Fusion began in November 2009. I went to work for a gas and oil pipeline construction contractor, and we were working in northern Montana, building a gas gathering system with HDPE sizes 3-inch through 12-inch. And I hired on as a laborer and had responsibilities like stringing pipe and laying tracer wire and marker tape and doing all the dirty grunt work that laborers do. And after a few weeks, I was taught how to fuse pipe. And by the end of the project, had really become the go-to Fusion guy on the job. And looking back, that's really kind of scary because I now know that then I knew just enough to be dangerous. You know, I didn't have enough knowledge or understanding of what I was doing yet to kind of have the lead role. But the project was a success. I never had any failures, which was very good. And we went on to do some steel jobs. And for the better part of the next year, I worked on a steel project, a 10-inch steel project and a 12-inch steel project, operating heavy equipment. After that first job, I got promoted to operator and was primarily running a side boom with the welders, but also spent plenty of time in a backhoe and eventually an excavator. And through my contacts with that employer, I was able to have the opportunity to work for Fusion Technologies. And I went to work for Fusion Technologies, and I spent 2.5 years as a Fusion technician, providing Fusion services throughout the region. And after a while, I decided to take a break and stay close to home. Billings, Montana is my hometown. And for the next 3 years, spent that time installing water, sewer, and a storm drain. So I've had the opportunity and the pleasure to literally work from the bottom of the trench up through the ranks and in several different industries of underground construction. So oil and gas and civil municipal, and as well as natural gas distribution with Fusion Technologies. So that really rounded my experience and background or knowledge of underground construction. And a few years ago, I had the opportunity to come back to work for Fusion Technologies as the operations manager. And as operations manager, under my umbrella of responsibility, I'm in charge of the planning and logistics and leadership of executing Fusion services to our customers, including with that the management of our Fusion equipment and our vehicle fleet and the maintenance, as well as a key role in the leadership of the health and safety of our employees at Fusion Technologies. So Fusion Technologies is a HDPE Fusion services provider based out of Billings, Montana is our headquarters. This year we're celebrating 20 years in business as a HDPE Fusion services provider. And we work all over the region around Montana, but also clear through Wyoming, Colorado, New Mexico, and heavily focused in West Texas over the last half dozen years. we provide fusion services in every industry that you'll find HDPE, from oil and gas gathering to natural gas distribution, as well as industrial processing or mining. Um, and we provide all sorts of modern fusion services, not just butt fusion, but also sidewall fusion, electrofusion, socket fusion, and we even do a little bit of extrusion welding. So um, over the last few years, our primary focus has been, or the dominant portion of our business has been, the mainline fast fusion services. But although that's been, kind of the dominant portion of our work, we've always maintained a core of fusion technicians with the skill and knowledge to provide large diameter fusion services, as well as technical services on more challenging or complex HDPE projects. And that's really what Fusion Technologies was founded on, was providing those large diameter fusion services and technical services on those challenging jobs. So over the last decade, we have fused north of 100 miles of natural gas distribution pipeline for Montana Dakota utilities. And MDU is the natural gas service provider in our region. They provide services to eastern Montana, all the Dakotas, parts of Minnesota and Wyoming, and out into Iowa. And they may have a larger region than that. But those are just the regions that we've worked for them in. So the gentleman in MDU that was directly responsible for hiring us to do a substantial portion of that work is Mr. Dave Yexley. And Dave was formerly Montana Dakota Utilities Special Projects Engineer. So Dave has been fantastic to work for, and just a good friend of Fusion Technologies. And we've had a relationship with the gentleman for a long time. So a few years ago, Dave retired from MDU and more recently accepted a position at Height Camp Construction as a consultant for a unique water retention pond or construction project in southeastern Minnesota at Mindak Farmers Cooperative. This is their sugar beet plant on the border of North Dakota and Minnesota, and only about 20 minutes from South Dakota as well. So Mindak Farmers Cooperative is a group of sugar beet industry stakeholders that own this plant to take their final product to market. It's mostly the growers and the farmers that own the co-op, and they needed to expand their water treatment capacity, so they hired Height Camp Construction as the general contractor to construct this new pond for them. So we were hired to come in earlier this year, back in March, I believe, to tie in 4 14-inch lines on the same project. The 14-inch tie-ins were straightforward in-trench fusions, and we took a Trackstar 618 with an in-trench kit. Myself and an apprentice, Tristan Tiller, went over to this project. Now, Tristan has been with us for going on over 2 years now. In fact, he spent about a year in our mainline fast fusion fleet, polishing his skills as a fusion technician, just fusing pipe after pipe. So we've moved him on to large diameter and getting him schooled up on the technical aspects of pipe fitting and working with HDPE and various methods of fusion beyond hydraulic butt fusion now. So it was during those 14-inch tie-ins that Dave briefed us on the 8-inch valve chamber tie-ins for this project. Before I get into the scope of work for that, I should describe how our piping system for this pond works. Is throughout the refining process, the sugar refining process, the produced water has some organic material left in it and is placed in this pond, where that organic material settles to the bottom and begins to decay and turns into a sludge. So the 8-inch system that we were here to help tie in was designed to recirculate that sludge, as well as inject air into this water to kind of help accelerate the bacterial growth and break down the organic solids. So they process this water and treat it and clean it, put it back into the ecosystem, and then the cycle, refining sugar just keeps going. So during the 14-inch tie-ins, Dave gave me these plans and provided photos of the 8-inch ball valves in the lower right-hand corner here. So we couldn't see these 8-inch valves at the time. It was March, so we still had freezing temperatures, and there was water in those. They had them covered with insulated blankets so that they would not freeze. And the valves, I had found out, were not part of the original design. And that's why they're so close together and so narrow and kind of stacked on top of each other. Is that was an afterthought. After the construction of the pond, MnDAC wanted to use that for water retention capacity while the pump and the valve structures were still under construction. So while I was there, the structure in the top right here wasn't in place yet. They hadn't even broke ground to build that. So that gave us about 2 months to plan and prepare for this project. And what we had to do was connect to the ball valves and run those lines out 35 foot and then offset both horizontally and vertically and enter the building, where we would stop with a flange adapter on the inside exactly 12 inches from the face of the flange to the wall. No problem. So we finished that project, brought these plans and drawings home to Billings, Montana, and met with my boss and mentor, Les Clout, and we started to put together a plan and an estimate to approach this project. So we had to decide what fusion methods and what equipment, personnel, and kind of work on schedule. So on paper, with 38 elbows, there was going to be a minimum of 76 butt fusions on the project and a combination of electrofusion couplings, when we would need them. So we planned that this would take about 5 working days on site, and it was a day of travel each direction. We'd have to leave on Sunday morning early, and then we'd return home the following Saturday. It's about a 10 or 11-hour drive from Billings, where our headquarters is, to Wahpeton, North Dakota. So initially we decided to try a Dynamic 28 hand pump machine. I wanted to utilize the hand pump because it looked like a small machine that would be able to fit onto those valves, and without having extension hoses and a vehicle chassis, thought we'd probably be able to move more quickly and have more freedom that way. So it was nothing against the contractor before us. Heitkamp had to hire a different fusion subcontractor to come in and install those ball valves later. As I mentioned, they were an afterthought and were not there to begin with. So those fusion technicians or that contractor had to figure out how to separate those lines enough to install those 8-inch ball valves. And really what that left us was just a stack and a pile of valves with almost no room to work with. And that was the first challenge that we had to overcome, is to figure out, well, gosh, how are we going to connect to those valves? I thought the Dynamac was the answer. Very optimistic that was the way to go. So in the few days leading up to the project, I believe it was just Friday when I was on the phone with you, Mike, and we were discussing the next generation of data logger 7, which we had volunteered earlier in the year to field test and kind of pilot those devices in the field to provide some management as well as boots on the ground perspective of the new hardware. So we were talking about the machines I was going to use and the scope of work, and Mike was very interested in why we would want to use a Dynamic 28. So I sent some photos over and kind of described the situation and the narrow workspace we would have. So Mike came up with a solution right away of a machine that was light and hydraulic, electric pump, and compact, and it really sounded like a better mousetrap. So right away I really wanted to give that a shot. So we had a challenge finding that machine in time, though. I mean, it was Friday and I was leaving on Sunday for the project, and would travel through Dickinson, North Dakota, and stop by High Country Fusion in Dickinson and pick up a Dynamic 28 because we didn't own one from our good friend up there, Michael Bryce, and then travel to the project. And that plan went according. And in the meantime, Mike got us in touch with Brett Stone, the sales channel manager for McElroy, and the search was on to find us a Dynamic, or an Acrobat 250. Found out that it was kind of a challenge to find that machine. You know, we live in the HDPE world, and so no one, you know, really in our rental connections or immediate rental connections had the machine, and you know, most were not aware that it would cross over to HDPE either. So by the end of the weekend, Brett had a plan to overnight a hot shot an Acrobat 250 up to our job site in Wapaton, North Dakota. So on Monday, May 4th, we kicked the project off with a Dynamic 28, along with my apprentice, Tristan Tiller, Mr. Dave Yexley, who worked with us shoulder to shoulder the entire project. And we had a crusty Traco operator to help us out by handling the material and swinging in our equipment, and, you know, just providing support with the excavators, craning our equipment in and out. The project started really well. It was a success, and the Dynamic performed, you know, just how I had hoped it would. You can see that it was small enough to fit in between those valves. And the one thing that I found that's kind of a drawback for us was I don't have a lot of experience with a hand pump machine, so there was really a learning curve to produce acceptable or favorable looking joint reports. You know, you're really married to that machine to maintain the hydraulic pressure, you know, where it needs to be within your interfacial pressure range. So that took a little bit of practice, but the machine worked pretty well for us. This is a photo from the end of the first day. So at a glance here, it looks like we're already a fourth of the way done, because that's, you know, 4.5 of the 16 lateral connections to the vault that we had to do, but there was actually 17 of them. And up by this ladder in the top right-hand corner, you can't see the 17th line that would connect to the vault chamber there. And also, I hadn't mentioned yet that there is a 10-inch line that was cut out and removed during the site prep for this project, because the bottom of pipe elevations were in conflict. They were very close to one another. So Dave chose to cut that out of the way and then order some 45-degree elbows and 10-inch electrofusion couplings. And once we had all the 8-inch work done, then we would just raise that 10-inch line afterwards. So we had a really good first day, and we're on track to finish this job on Friday as planned. However, it began to rain late this afternoon, and rained very hard all through the night and into the next morning. And we knew that was very bad for our schedule, and wasn't going to be, I just didn't know how long it would take for the site to dry out. But we drove out to the job site the next morning to, you know, have a look and see if we could do anything. And morale really dropped as the crew gathered this morning, and this was what we had to work with, and it's still raining hard, so we couldn't work on this day. You know, the spirits and morale were just kind of drowned in the mud, because this was going to set our schedule back and mean that we either would have to make up for it on Saturday or stay over the weekend and finish on Monday, because no one wanted to work on Saturday. That Saturday was the opening for fishing season in Minnesota, and many of the gentlemen on our crew were residents of Minnesota, because Wapaton, the town where we were working, is right on the border, including our leader Dave, who is an avid fisherman and fishes all over the country and probably all over North America. They had been looking forward to going fishing for quite some time. So there was some grumbling, and no one was really happy about having to come in on Saturday. So now the challenge for us was to work double time and try and figure out how to get this project back on schedule. So the next morning, we spent about an hour scraping mud off of the job site with skid steers and getting set up, and only had one fusion made with the Dynamic 28 when we got a radio call from Heitkamp's warehouse that our Acrobat 250 had arrived. So the crew brought it out, dropped it off for us, and a nice crate, and we started to take the machine out of the crate and check it out. And you know, took a few moments to marvel at the machine, for its design and kind of skepticism. It's very small and lightweight, and my concern is that it wouldn't be strong enough to hold up to HDPE, or that because it's so small and light that it might have some flex in the carriage, which wasn't true. It turned out it's a very rigid, and although small, it's very strong and robust, and had plenty of strength and pressure to fuse this 8-inch DR11 that we were working with. So that wasn't an issue at all. And although we had never worked with anything in the Acrobat series before, it was still very similar and familiar to us, along with the equipment in the Pitbull series and Trackstar machines. It has an identical hydraulic control manifold and hydraulic controls, so there was no learning curve with that. Out of the box, we had this thing on the pipe, and this is a photo of the first setup, and we were setting up the first fusion within an hour with this machine. So went very smoothly. I just want to mention the data logger really kind of bailed us out and saved us on this project, because one evening we forgot to charge the device and had left it in the work truck. So the next morning we came to work. This is Wednesday morning now, and the third day while we're in North Dakota, take it out of the case and there's only 30% battery. But Mike had sent it with spare batteries, which is really cool because we didn't have to shut the device off. You can hot swap the batteries. So we really tested that 14-hour battery life, and it should go beyond that. But once it got below 10%, we swapped batteries. So not sure how long it would really go, but it performed very well for us. This was the first, one of the first projects where we would use it all day, every day, all week, on a job. And it was a tremendous success right from the beginning. And we're still very happy with the Data Logger 7 and this new tablet. So this photo kind of shows how narrow our workspace is, and is a really good illustration of just, how tight of a workspace you can put that Acrobat 250. It's helpful not to have the hydraulic control manifold attached to the carriage, because that makes it narrower and lighter. And in this position, and especially for the valve that's nested underneath this one right here, I don't think the Dynamic hand pump would have worked there. Probably would have ended up shooting electrofusion couplings, just because there was no room for the control manifold or the pump on that machine. The handle itself would have been in the way, especially for that valve that's nested underneath there. And there was two situations that we were in on this project that were exactly like that, where I probably would have just used electrofusion couplings, but thanks to the Acrobat, we were able to hydraulic butt fuse that. So a little spec about the machine is that it weighs 38 pounds in 3-jaw configuration, and that's the way we used it for most of the project, because it was just lighter that way in 3-jaw. So that's between 38 and 54. That's about the same as a 2.6 Pitbull manual fusion machine. So this is very light and it's about the same size, and it's a 2.8. So it was everything that we hoped that it would be, which Mike, promised it would. It's lightweight, compact, and has some unique design features. If you look at the back of the jaw, there's a double hinge jaw design, which initially was kind of a head scratcher. We didn't know what the purpose of that was, but very quickly, realized the value that you know, you have adjacent obstacles like these valves, or if you were to use this machine for an interior, you know, piping application where you're putting pipes up in the ceiling, those double hinge jaws are designed so that you can weave in between those adjacent obstacles. So that was a very handy feature. The machine was a, you know, it's a 110 volt electric hydraulic pump, which is very pleasant to work around because it's so quiet. Those of us that work with, you know, motorized equipment become kind of immune to the noise and that noise level, but it's so nice not to be able to have a conversation with somebody just 3 foot away and not to have to shout over a motor or an engine. So that was fantastic. I like this photo because it shows us all the elements or pieces of this fusion machine and this system except for the heater here. So that HPU over on the left-hand side performed very well for us. You can move it into place very easily. One person can pick it up by the handles and wheel it into place, or if need to, you know, 2 people can easily carry that machine because there's handles that extend from both sides of it. It's much lighter than something like a 7,000 watt generator. It's like half that weight, so super handy. And the hydraulic hoses have a modern hydraulic twist disconnect coupler, which is the flat face QDs, so they're very easy to keep clean. And one of the things that this HPU does very well is bleed the pressure off. So in between fusions, when you disconnect your hydraulic couplings from the top works, there's no trapped pressure in those hoses and you can easily reconnect. Anyone who's worked with hydraulic equipment with auxiliary attachments knows how frustrating it usually is if the machine doesn't go through the process to properly bleed down the hydraulic pressure, then there's trapped pressure and you cannot get those QDs to work. So we never had an issue with that on this equipment. It worked very well. And the control pedestal or cart where the controls for the carriage are attached to is very handy and useful. In between fusions, you can coil the hydraulic hoses up around that kind of that protective cage and keep them stowed very nicely. The platform on that cart is designed so that you can pin down the carriage or maybe the HPU for the 160 or heater. Everything has you know, toolless pins to attach so that this machine in between fusions is sort of bundled on that cart and you can just move it around your job site very easily. And that hydraulic control manifold comes apart from that pedestal or that cart as well. You just remove a pin and just in a matter of seconds you can slip that control manifold off of there and then place it anywhere you need to in any sort of improvised position, which would work really well in a man basket, or like I used it on top of scaffolding. And later in this job, at the end of the project, when we tied in the 17th line, I actually had to work on top of the first 16 8-inch lines that we installed. So there wasn't a good stable position or flat surface to set that hand cart up there. So I just unpinned that hydraulic manifold and you can rest it, you know, near the carriage within reach while you make the connection. So that mod as the project progressed, we filled our excavation with pipe and our workspace was getting smaller and smaller. But because we could move these pieces around of the system, managing our workspace was still very easy. So throughout this entire Acrobat series, I want to highlight or make note that you do not need an Allen wrench or any tools to configure that carriage to 3-jaw, to go from 4-jaw to 3-jaw, or to take the pedestal off. You shouldn't need any tools, which is great because if you're on scaffold or something and you drop your Allen wrench, then you know that's not only a safety hazard for someone below you, but it's just frustrating as well. So I love the design and the theme here that we don't need tools. You can turn this machine into a 3-jaw setup in just seconds. Literally, there's some slide pins on the sides of the inside static jaw, and you pull them back and swing those arms out of the way, and you can separate the 3 jaw from the base plate and the 4th jaw in like 5 seconds. It's very cool. So the Acrobat was wonderful for us for the volume of fusions that we had to do. Really thankful by this point that we had a hydraulic machine, and I wasn't married to the top works while we were cooling to create good looking joint reports. This Acrobat makes the most crisp, clean joint reports that I have ever seen. And I look at a lot of them at Fusion Technologies. One of my responsibilities is to make sure that all of our joint reports are reviewed before the contractor or customer installs them and buries them. And with 7 fusion crews going, mainline crews and fast fusion machines, sometimes I have like 700 reports to look at every day. So we need to be able to quickly make a go, no-go decision on the quality of that report or that fusion. And with the Acrobat, they are just very clean and sharp looking graphs. So that was fabulous. I think the Dynamec is still a great machine, and if you just have a few entrenched tie-ins to make, I think that's really the way to go, especially if you are going to be in a trench in the mud and the snow. You don't want to be dragging extension hoses through that. It's very easy for a couple workers just to take the Dynamec out of the back of the pickup and put it in a trench and make that final connection. But for a large number of fusions, I think that having the hydraulic machine is really the way to go. So the Acrobat, was really shining for us on this job. A unique design feature of the heater that I haven't mentioned yet is that heater is designed to hook and latch onto the guide rods of the carriage. And I know that's designed so that it can be used upside down for water treatment plants or interior work, maybe a water park or something of that nature. But what's really handy is that it also latches into the insulated heater basket. So I thought that was really cool that you could just pick it up by the handle and carry it, and it's not 2 separate units like the most of the pit bull equipment that we're used to working with. So I really enjoyed that feature as well. So for the first 2.5, 3 days of the project, I had been using electrofusion couplings to make the final upper connection to the valve chamber. And remember, I mentioned that the flanges on the inside of the structure had to be 12 inches from the face of the flange to the wall. And I would measure those dimensions, mark the pipe and cut the pipe, and peel the ends and install my electrofusion coupling, and then start to adjust the alignment and the pipe deflection throughout that coupling. And in order to get the alignment and restraint on the coupling where I needed that, it would throw off the specification on the inside of the building. So it was very difficult and time consuming to achieve both criteria, to create a quality electrofusion joint as well as maintain the 12-inch spec inside the building. So we decided to give the Acrobat a shot. It had been working very well for the lower connections, but we wanted to try it, on an upper offset where, the weight would be sagging the pipe, but I thought with the jaws we wouldn't struggle with alignment as much, and it was very true. So this is a photo of the first installation of the carriage for an upper connection. And you cannot see it, but I'm standing on scaffold 6 foot off the ground right here. So it's fantastic because the machine was lightweight and small enough, it's easy to position. And with the jaws to help with alignment, alignment was no longer an issue. And I didn't have to peel the pipe, and we didn't have any struggles with dimensions or alignment. So that was just a faster process, and also was a more accurate outcome because I was able to just nail my 12-inch specification inside the building. So by the end of the 3rd day, the Acrobat had replaced the 8-inch electrofusion couplings as well. So this is a photo of that first one as well. And what you can see that I'm doing here, I have my tape measure in that carriage, So I'm measuring how much pipe I'm facing off, during the facing stage. So creating a fabricated section of pipe, a specific dimension from the face of the flange to the center of the elbow, that's not really complicated or difficult, but you need to have a thorough understanding of what's going on and how to achieve that, how to build that. So you need to know how much linear distance is going to be lost when you melt the pipe ends and when you join those ends and create the fusion. And that's something that we had been observing from the beginning of the project, and something that my apprentice Tristan was practicing. We had brought our Trackstar 412, so he was up above fabricating the offsets and the elbow sections, the vertical sections of pipe, and practicing that technique as well, so that he could make those offsets the exact length that we needed from center of elbow to center of elbow. So I'm doing the same thing here, and you need to observe that, or do a couple practice runs so you can figure out what that distance is, because it changes with every pipe size and DR. So it's not the same for 8-inch as it is for 16-inch. But with the Acrobat, we were just able to nail that 12-inch specification. So it turned out that it was a very precise machine. So this is the second upper connection when we were using it in 4-jaw configuration, which did a much better job of alignment. And I knew it would, but we wanted to try 3-jaw configuration first, just to find out what it was like and what we could get away with. And I was worried that the base plate in that 4th jaw might have enough added weight that it would sag that upper line and I would have some alignment issues. But because this carriage is so rigid and lightweight, really, I mean, only at 53 pounds in 4-jaw configuration, not including the heater, but that was still not an issue. It was very easy to mitigate, any flex or misalignment that we had. So not a problem at all. The Acrobat, turned out to be easier to position, better alignment, and that was an overall faster process and a more accurate outcome. So at the beginning of the job on the first day, we found that the 8-inch pipe had enough flexibility that we were able just to bend it into place or hold it in place with our excavator, and we were able to delete the elbows or the lower offsets. So that saved some time. However, I think the real superstar of the project was the Acrobat 250. It increased productivity and increased fusion quality because our joint reports were better with the hydraulic machine, and the increased capability now because instead of using both a Dynamic and electrofusion processor, I could just use one machine. And we used MOC on this project as well, so that trimmed off a considerable amount of time. We estimated this project with ASTM, F2620 and conventional fusion methods of 11 minutes of cool per inch wall thickness, but then we actually brought in the data logger 7 with the DL6 software and used MOC. So we were able to put the project back on schedule and get back on track and finish this on Friday afternoon, which was awesome. I mean, by Friday afternoon, the morale had risen and there was lots of smiles and high fives. Everyone was very pleased that we were going to be done on Friday evening. Now, we had to work long days on Thursday and Friday, but we completed the project very near schedule. So that was awesome to pull off that victory, and the Acrobat and the data logger, with MOC played a huge role in that. So total fusions for the project came to 76 butt fusions and 8 electrofusions. Of those butt fusions, 38 of them were made with our Trackstar 412, 12 of them with the Dynamic 28, and then 26 of them with the Acrobat.
Casey, that's a great story, and your photos are just fantastic and really show everything that that you all had to work with. And you know, I know you make it sound easy, or it's very day to day, but it's impressive, and we know that it's not that easy. And then for those others who may not know, Casey referred to MOC, that's McElroy Optimized Cooling. So that's McElroy's patent pending cooling procedure to reduce your cooling time. So more on that if you're interested in. But Casey, what a great story! I think the Acrobat is just truly a game changer for the HDPE industry. It's small, compact, lightweight, and we're fusing 2 to 8 inch HDPE pipe with it, and just a major game changer. And have you guys, are you going to, where are you looking to use it, and how's it fitting into your business model?
Yeah, so it's certainly given us a different lens to look through and an approach to future projects because of its capability. Now, we've looked at jobs like, smaller diameter, like 3-inch, which we want to hydraulically, fuse and be able to data log. We want to data log everything. So that's going to replace electrofusion couplings, and we're going to use it for a lot of that. So there's more of a push to be able to data log even the really small diameter, and having the joint report is becoming more and more important each day for the project engineers and project owners. So it's going to change the way that we approach and estimate, some of these future projects, because it was faster and had the capability of being multi-use. We didn't have to take a processor and use the expensive electrofusion couplings as well. So it's a time saver,
Yeah.
and save some money. So it's worth the value.
And you actually came under budget on this project, right?
Yep, that's what I'm told. Project manager Les Clout said that we saved some money and still finished on schedule even despite the rain day. So
That's awesome.
yeah, we saved like 20% of in time savings, and that right there is probably what what made it such an eye opener, game changer for us, truly.
Yeah, that's fantastic. And again, to your point about being able to data log, and that's what really gets me excited as well, is to be able to data log small diameter. And that's where I think there's this huge potential throughout many different industries using HDPE pipe. And Acrobat is just prime for this.
All right. Casey, welcome. Well done. I welcome to our guests to the question and answers on this case study on how Fusion Technologies and Casey Britton integrated the Acrobat platform into a really challenging job site. Now, Casey, I really gravitated towards your story just because I think it's exciting to see someone take a challenging situation and come out a winner. You came out on top of this thing, and I could, from the sidelines, attribute it to several things, but I think this case study could have easily been, Fusion Technologies winning story, if you will, as opposed to the Acrobat. The Acrobat just played one piece. You had so many challenges on this job site. Help us paint that picture a little bit more.
Yeah, it was a pleasure. Failure is never an option. So just finding more tools to help, aid in that victory or successful project, and finding new ways to continue to make our projects more profitable or more efficient. That's kind of what drives innovation and continuously drives contractors such as ourselves to, just look for a better way to do things. So the Acrobat and the data logger, really helped with that on this job. And it was it's a good opportunity to go sharpen those skills. And the more you do it, the more proficient and the faster we get. So looking forward to more of these projects, and we're certainly going to use this equipment in the future.
Right.
Yeah.
Well, I'm a big fan, first of all. And to watch you go from having that initial plan, from the drawings, and to the 10-hour, 11-hour drive to the site. You had the weekends bookending this sort of 5-day planned work period. You had the fishing season. You had the rain come through.
Yeah.
You had, the hand pump was good, but not just right. And you discovered the Acrobat, but you didn't have one. You didn't have access to one. And all of these things stacked up, and you came out in your favor.
Yeah, it did. It really did. With every project, there's always unexpected, things or events or something. Then it's you just have to adapt and overcome. So that's the great thing about doing the technical work, is that there's never two jobs that are the same. It's similar principles that get you through each one of them, but looking at a set of plans or blueprints, it can be completely different once you get there. So we try very hard to think of everything that we can and have a plan B and a plan C. It's you just you cannot fail to plan. I like to say that one is none, two is one. So we take double of everything and try and have two different approaches or two plans. Sometimes you don't have that, and you're really, there's only one other option, and that is forward or to use what you got. So yeah.
Wow.
It's a lot of
That's
fun.
Great. Yeah, we're getting some good questions in here. I'm going to at least initially start with the ones rising to the top. The first question here, if I can manage my technology appropriately here. Did the Acrobat setup provide you with sufficient hydraulic power, and did you have any type of drag limitations associated with using that Acrobat HPU, which seemed to be very unique, probably to some of our audience here today, as it was a little bit different configuration than they're probably used to seeing.
Right. So we used the Acrobat 250 with the low force cylinders. I believe they're low force anyways. Their total effective piston area was 0.9, and McElroy does make that machine with 0.11 or 1.66 cylinders. So high force. Didn't use that one, and I wasn't able to put it in a drag situation where I could find maximum or ceiling for everything that we were doing with up to 40-foot lengths of that 8-inch 11. I had more than enough. I believe it's there, certainly. I don't know if you could say we could do 4 or 5 joints, 250 foot before we reached our drag ceiling. Not sure. I think that it has plenty to get that done, though, especially if you were to order it with the high force cylinders.
Gotcha.
Yeah.
Next question I'm going to throw out from the field here. Let me see. Yeah, you mentioned briefly you used McElroy optimized cooling. For those who perhaps haven't been down that path, can you briefly share your experience with that?
Sure. So when we had first heard about that and it was initially released, we had a tremendous amount of skepticism. Trust McElroy, but we wanted to verify it. So we did some in-depth testing of our own to find out what the bead temperatures were upon release and how rigid the pipe was, and just kind of move into it very slowly. And we started to use it on freshwater projects and agriculture projects until we were more comfortable with it. But there is a significant reduction in cool time, and we have created our own standard operating procedures on when we will and we will not use MOC. So a situation where we would not use it is in a tie-in situation, perhaps on a radius, or anytime we would have to handle that pipe roughly soon after. MOC still is like the conventional ASTM standard, where there should not be any rough handling for an additional 30 minutes afterwards. We've been very successful with it. I think everyone has been. Really happy with it's increasing our efficiency and helping us capture more profit, right?
That's great. That's what it's about, right?
That's the bottom line.
That is the bottom line.
Yeah.
Hey, Casey, I'm going to move us through here kind of quickly because we're limited in time and your story's so interesting.
Sure.
You mentioned that Fusion Technology serves a variety of industries, you have a variety of market segments. This one was quite interesting, but I'm wondering if you have any considerations for using this platform, the Acrobat specifically and Data Logger, to innovate into other market segments. An example being the natural gas distribution business, which you guys are active in. Do you see applications where this technology could help differentiate you there or provide additional value to your customer?
Sure. Yes, we do. It's interesting with natural gas distribution was that, decades ago, they embraced HDPE and MDPE, but they do seem much more slow to adopt the latest equipment and more modern methods. But I think the Acrobat is an ideal machine for distribution because those are commonly, new tie-ins or services are in very narrow workspaces, just like I was, much narrower. In fact, they might remove one piece of concrete or put in a service box that a person has to go down in, that will be 4 foot deep and the workspace may be, 2 foot by 3 foot. In that situation, this is where the Acrobat would be really useful. A lot of that in city, we did a large rehab here in Billings a few years ago, where they slip lined most of the new HDPE in place, and then it was in trench right next to a very busy street and in between a sidewalk on the other side. So I think as natural gas side of the industry starts to see the advantages of it, they've just got to try it, and it takes them a long time, it seems like, to vet these products, but they'll be happy with it when they do.
Right. Along the same lines, and maybe relative to potentially the natural gas industry in general, but to this particular project, the next question is relative to the use of butt fusion versus the electrofusion alternative that you said would have really been your next best go-to in several of these challenging workspaces. Did you guys determine any cost savings, or did you run those calculations? Could you share any of that with us?
Yep, absolutely. So the electrofusion was the backup plan, or the option B, and for an 8-inch electrofusion coupling, that the coupling itself would have been right about $100. Okay, and then our electrofusion processor, the scraper, the generator, or not the scraper but the peeler, we have to be able to charge for all of that. So to have the Acrobat do everything, not only save the material cost, but also we were able to we will be able to pass on that savings to the client as well, because we're using less equipment. We're not going to bill them for it. So yeah, there's significant savings. You bet.
Gotcha. Yeah. In listening to your story, it was interesting to see your adoption, acceptance, and utilization of technologies like fast fusion comes to mind. The hand pump that you didn't really have a lot of experience with, data loggers and McElroy optimized cooling, then to the Acrobat. It seems that Fusion Technologies is very much in the mode of innovation and trying new things and seeing where the best fit is. How do you, as a company, take those first steps, that leap of faith, if you will, or that hey, let's try this. The worst thing that can happen is it's not going to work, and we're going to go to the next thing. How do you, as a culture, how do you get that going? We've got about 5 minutes left here.
Yeah, utilizing new equipment is I think it's really exciting if you're into gear and trying new things. But we know what would work and what we can rely on. So I don't feel that there's much risk in it. The only risk is the capital to rent or purchase the equipment and go out and try it. So trust but verify. It may not. We have found some things do not perform the way they are advertised they will. So and how can we get that to perform for us? And think outside the box. It's that innovation to find kind of an unorthodox way to accomplish something, and it's through that you'll find more efficient ways and capture more profit.
Yeah. Casey, as a manufacturer, it's always interesting to see as we innovate from a product standpoint, but then once companies like yours take our tools to the field, it's amazing to see what you can accomplish given tools with a handful of capabilities and some unique features. You take these things to places that we perhaps haven't even thought of. So that's where the learning is as a manufacturer. And so it's great to be partnered with a company like yours. And the whole topic of innovation and adoption, I do want to give Fusion Technologies a little plug. There's coming up here at 2:00 Central Time in just a couple of minutes, Les Clout, I believe his presentation on integrating the data logger into your overall business is coming up. Another really fascinating, cool story. And I would encourage everyone to take part in that and see if there are pieces they can take away from it. In closing, we've just got a couple of minutes, Casey. Anything that didn't come out today in your presentation, or any closing thoughts for our guests?
The Acrobat's durability and toughness as well. I don't think that I got to that during the presentation. It's very strong and rigid, and I tested that, not intentionally, but it was by mistake that I tried to break the machine or tear a jaw off of it. The machine's full hydraulic force was up against a jaw at one point and an adjacent valve, and I didn't snap a jaw off. So that really surprised me. Very happy that I didn't break it on the first project and and have to go back to the hand pump. But don't be afraid that it's going to break and leave you stranded. It will not. It was very strong. It's tough.
Well, that's great. Thank you for that. I want to bring a point up, and something that I took out of early on in your presentation was, I think a key to this success in this particular project was just the communication that you had with Mike Pacheco and your distribution, your supply chain, and the coordination and cooperative efforts that went on there. Rather than relying on what you know or what you have experience with, you were open to new ideas, and we were open to trying some things that, perhaps were a little bit on the edge, if you will. And I think it worked to everyone's benefit, but I can't overstate the value of that communication, cooperation, coordination in efforts to accomplish these common goals.
Yeah, that's kind of the advantage of McElroy, is being able to call somebody at customer service or tech support, and if no one answers right away, they get back to us very quickly, even on the after hours or on the weekends sometimes. Jeff Ross and his team have been really helpful, and Mike and Brett were great to work with as well. So that's why I try to tell our guys too, is always be open to hear different suggestions and different approaches. Don't get to the point where you think that you have it all figured out and there's one way to do something. Don't get stuck in that dogmatic mindset that this is the only way to do it. Our industry, even the material itself, may change so much in the next decade that we could be, you know, well, just look at the next gen track star, you know, and the new pipe materials that are coming out.
Right.
Our world is changing rapidly.
Yeah.
So
Yeah.
hang
Well,
on.
with that, Casey, thank you so much for sharing with us today. Your story is inspirational, and we appreciate your business, of course, your cooperation, your efforts, and keep up the fine work.
Thanks. Appreciate it, Chris.
Thank you.